Hello everyone. What I'm going to teach you here in this video is how to use angles of elevation and depression. Now this worksheet, which is my class notes, you can find on Moodle, and if you want to pause the video and pull this worksheet up, you can see it and fill it in as you go and just pause the video as you're working. That's the nice thing about having a video on YouTube. So here we go. We have two different types of angles in this section. One is an angle of elevation. So let's say you are this person and you are looking in the distance. If you look up, think about what you're seeing. This is your line of sight, and from your eyes, this horizontal up is called an angle of elevation because again, you're looking up. Whereas for instance, let's say right here, this is your line of sight right here. Let's say you are up here. That is you, and you are looking down, maybe the side of a cliff. Don't get too close. But as you're looking down, and this would have to mean that your eye was right here for this to actually be the angle of depression. So typically there's some height here because your eyes aren't right on the edge. Some of the examples that we'll be doing today, we're going to talk about the angle of depression coming right down like that. Again, you're depressing, you're looking down. So right down here on this example right here, they take you through this problem. So let me explain it a little bit. The angle of elevation from point A to the top of a cliff, here's our cliff, is 34 degrees. So that's our angle of elevation. If point A is 1,000 feet from the base of the cliff, how tall is the cliff? So here we go. X is the height, and with respect to this angle, which of our trig functions, remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Which one of these three relates opposite and adjacent? Well, of course, that's tangent. So what we're going to do is take the tangent of 34 is equal to the opposite side over the adjacent side. So x over 1,000. And now we're going to solve for x, which means on both sides we have to multiply by 1,000. Note that's stated here. And then you're going to use your calculator, and the height of the cliff is approximately 674.5 feet. Now remember, when using your calculator, make sure that you have checked in your mode that you are in degree mode. And then you do 1,000. I'm just going to pull it up here so you can see it, times the tangent, whoops, but you can't see the screen there, okay, of 34. And then when you hit enter, there's your answer, and you're rounding to the nearest tenth, so 674.5. Now, look at this problem right here, and I will post my solutions to all of these online, but if I look at this first problem here, this hilltop problem, the angle of elevation, and this problem models this one up here identically with the exception of the numbers. So I've got my angle of elevation is 49 degrees, my distance is 400, I don't know my height. So again, with respect to 49, this is opposite and adjacent, so I am setting up the tangent of 49 degrees is equal to the opposite side, which I don't know, times the adjacent side of 400. So here you would multiply both sides by 400, and you'll notice over here that it's going to drop off. These will both equal 1, so we can cancel that off. And then we'll find that x is equal to, and we're going to take, again, 400 times the tangent of 49, and we're going to round to the nearest foot, so 460 feet. That will be your answer for this problem. All right, now if you look at number 2, and I have the answers written off to the side here as well, but I didn't show my work, so that's what I'm going through to do now. Right here, you're looking for the angle of elevation. Here they gave it to you, here we're looking for it. So we're going to have to use our inverse operation. So you'll use the second key in conjunction with whatever trig function you choose to solve this problem. So let's look at that. Find the angle of elevation, we'll call it x, of the sun when we're given the opposite and the adjacent. So again, this is the tangent. So we're going to find the tangent of x when we have 12.5 over 18. Now that's where we're going to take our calculator and we will do second tangent, because we're looking for the angle measure of 12.5 divided by 18. That gives us 34.77. We'll round to the nearest degree, and we're going to call that 35 degrees. So the measure of angle x is 35 degrees. Our skiing problem. Now you'll notice I added a little bit to this worksheet. I was told that the slope is 1,000 yards and the height that the skier starts at is 208 yards high. Okay, what is the angle of depression? Now notice where that is in the picture. Okay, it's here. But there's a couple ways you could approach this. So for instance, these segments here are parallel, so we know that these are alternate interior angles. So maybe you want to do, oh, well, let me look for this angle. They're the same, so it doesn't matter. So with respect to this angle, I have opposite and hypotenuse. So I would use sine. Or I could leave the picture the way it is, call that angle x, and if this is 208 yards high, so is this. And again, I could use sine, opposite over hypotenuse. So the sine of x is the opposite over the hypotenuse. Don't forget that we have to use inverse sine of 208 divided by 1,000. And if I round to the nearest degree, I'm 12 degrees. So the measure of angle x is 12 degrees. And finally, this last problem with air traffic controllers. So we have a 120-foot high tower, and the air traffic controller observes an angle of depression of 19 degrees. How far from the base of the tower is the airplane if the airplane's over here? Well, here's my x. So a couple ways you could approach this. If this is 19, so is this. So the tangent of 19 is opposite over adjacent. Or you could say, well, if this is 19, that makes that 71 because that's a right angle and these are complementary. So you could do the tangent of 71 is opposite over adjacent. So just notice where your x is. It's in a different location. So let's say we did the tangent of 19, using this one here, opposite over adjacent, 120 over x. I could set it up like that. Or I could set it up as the tangent of 71 is opposite over adjacent. It doesn't really matter which one you do. In this case, to solve for x, you trade these out. So you have x equals 120 over the tangent of 19. Over here, you multiply both sides by 120. So you have 120 tangent 71 equals x. Either way, you're going to get the same answer. So if I take 120 divided by the tangent of 19, I get 348.5. Okay, or if I take 120 times the tangent of 71, I get 348.5. Okay, so either way, you get the same answer, and that is in feet. Okay. Your homework for this section is from the textbook, and I just wanted to show you really quick what I'm expecting when you turn this in. Now again, remember you can pause this video and write down these problems. I posted them also, so however you get that information, that's up to you. But this is what I am looking for. Problem number 1 in the book has a picture that looks similar to this, and you're asked to find side x. All of these problems are word problems. I'm just helping you set up the pictures for them. So here you're asked to find side x. So you're going to take the tangent of this angle is equal to the opposite over the adjacent. And I'll let you fill the rest in. This guy down here, number 7, notice this is number 1, this is number 7. It's 528 feet this way, 2,000 feet this way. You're given the angle of depression and asked to find it. Number 13, as you look at the problem in the textbook, don't forget these sides are parallel and congruent, so this 995 is also that 995 up there. It's just not written there. You may want to approach the problem that way. It's up to you. And there's a couple more problems here. Number 15. This one I set up a little bit for you. In this particular problem, you had your 34 degrees here. You don't know this length, and this is 162. So you would take the tangent because we're doing opposite over adjacent. And number 19 does have 2 parts, parts A and B. There's a little intro to the problem, and then you're given these 2 problems, and you're asked to find the answers. Again, I am asking you to show me your diagram and then the work that goes with those. I hope this has cleared things up for you for this section. Again, this is just an application of the previous section. Surveyors actually use this information when they're doing their work. So if you have any questions, send me an email. And I'll be looking to try to do Zoom here with the class next week. Thank you so much. Have a great day.